Now, uh, common resiliency failure in integrations are missing or weak retry logic. So integration fails when API timeout or return 429 kind of exception, too many requests kind of thing. But there's no proper retry or exponential back off. Without it, transient failure becomes a permanent issues. And I have seen this kind of challenge many times in my development experience. The next one is no dead letter queue for handling. So message that can't be processed get lost. So sometimes, if people are not very experienced, developers are not very experienced, they forget to create a DLQ, and it could be a disaster if it's not managed properly. Poor error propagation, and this is very common in development. Error occur in logic apps or functions, but are swallowed silently or logged locally, and system doesn't know what happened to it. So without centralized error reporting, operations team can't act fast, and it's leading to long downtimes. So another one is lack of idempotency. When retries are triggered but not idempotent, duplicate records appear in target systems. So when we implement integration, we need to think about making system idempotent to make it more resilient. In some cases, there is no circuit breaker or fallback. That can be a problematic as well. Sometimes in hard-coded dependencies or endpoints. So integration tied directly to static URLs rather than referencing it. Credentials break during migration or I've seen this thing and cut over. So in the last company, there was massive issues when we migrated API management from development to production, and there's so many information was missing. And when it went into production, didn't work because information was static and it was stored in specific to the development environment was in configuration files, and it didn't work because there was no proper deployment and migration. uh, no observability or correlation ID, and this is also very common. So when we develop various services and we forget about providing correlation ID to connect these services to each other, and when we use KQL on our app Insight, we find very difficult to track one end to end, and this is really a problem in development. So we need to think about those things as well. Single region or single point of failure design. So all components, logic app, function, storage, service bus, deployed in a one region, and zone means one outage can take everything down. So need to think about how it will work if something goes down. If need to be make it resilient, geo redundancy, and fault isolation. Poor deployment and rollback planning, I just mentioned earlier with APIM, failed deployment or bad configuration shouldn't be cause prolonged outages. Without blue-green deployment or version rollback, teams spend hours manually recovering from avoidable incidents. So we need to be careful about those things as well. So those were the common problems, and mitigation strategies could be implement retries and exponential backoff, use DLQ for message recovery, ensure idempotency. Basically, what I said earlier, not to do. Now we have to do those things from mitigation point of view. Apply circuit breakers or fallback logic, mostly in APIM, but could be in Logic App or in Azure Function as well. Centralized logging and correlation. So we have to make sure uh, we have common app insight for all the services we are using for a system. Uh, so we need to make sure that we have commonly used and we log everything in that application app insight. Um, Deploy across regions and use geo redundancy. We have to make sure that something goes wrong, then services are available. Automate rollback, use blue green release. Um, So we have to make sure that when we automate this all, there's some rollback plan and some scripts written for something goes wrong. It should automatically roll back and should bring the system to the state it was before deployment. And the final one is continuously test and monitor for failure. So I have seen this last one not done properly in production. So we try to avoid testing those things in production. So we need to make sure that we test all those things and make 100% sure that everything is working. If something goes wrong, its system should not crash and should not the business should not stop. Process should keep on working. Now, how to design resiliency? So there are a couple of steps we need to think about. Define, first is define, then design, implement, test, deploy, monitor, and response. Very common. It's not something new. Define. Start by defining what resilience means for our integration. What failures are we are protecting against? Transient regional dependency. We discussed earlier type of failures. Set clear targets, RTO, RPO, MTTR, uptime expectations. So we have to think about all those resiliency matrices, and we have to document all of them in our design document, high-level design document, or mostly it happens in low-level design document. So we have to make sure all are documented. Then design, we have to architect our solution to survive failure, not avoid it. So we have to design such a way that if it happens, it should survive, the system should recover. Then we have implemented, turn the design into code, use logic apps, functions, APIM policies, and apply retry, back off, rollback logic, and store all the credentials, secure keys into Key Vault. And we need to make sure that we capture telemetry in App Insight, ensure that each step has error handling. So, and another thing is we need to think about infrastructure as code. We can use Biceps or Terraform to ensure that we have resilient design and it's repeatable. Then we have test. So don't wait for production failure. We have to simulate them. We have to try that what we have implemented is working. Our resiliency strategies are in place and it's working. So we have to make sure those things. So we call it chaos testing for integration. So we have to do chaos testing to validate that our resilience strategy is vital, is and working. And then we have to deploy. We can use various type of deployment, blue, green, or canary deployments. We can use Azure DevOps, or there are others as well. We can use normally I use Azure DevOps. If the new version fails, switch traffic back instantly. Include rollback steps in your pipeline, and resilience in deployment is just as critical as in runtime. So we need to make sure that our deployment, if it fails, it should automatically roll back to the original it was before deployment. The next is monitor. So we have to be observable. Means system should be observable all the time. So it must collect telemetry data from App Insight, Log Analytics, or Azure Monitor. It should track like latency, throughput, failure rates, and all those things. It also alert the team when threshold are breached. Don't wait for a user to notice it. Basically, it should be automatic. It should not wait for trying to complain about these things. Then we have respond. So even the best systems fail, and it's not an exception, it happened. So what matters is how we respond. uh, we need to analyze logs, conduct root cause reviews and or analysis, and we have to refine the design, feed every incident back into resilience plan. So we have to go in a continuous iteration. So we have to keep on improving our design and our documentation, as document, and we have to document all of those things. So we have a robust system after few iterations. Over time, this builds an operational maturity and turns incidents into learning. So this was